Hi students, today we are going to discuss trigonometry formula by using vector method. Example 6.5. Prove by vector method sin alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. Already work out the problem. Cos of alpha minus beta. Cos of alpha minus beta equal to cos alpha cos beta plus sin alpha sin beta. Now to prove sin alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. Taking the unit circle is radius is 1. Draw a circle. That is the radius is 1. Where the center is 0. The center is 0. Taking the 2 points P and Q. Taking the 2 points on the unit circle. Given the angle is alpha minus beta. The angle is alpha minus beta. Taking the 2 points lies in a first quadrant. Taking the 2 points. First one point is P in first quadrant P, and the second point is Q lies in a first quadrant. That is the x-axis. This x dash, y and y dash. Now OP makes an angle with the x-axis respectively is alpha. This OPX that is alpha. The angle is alpha. The next one OQ make an angle is beta. Now join the line OQ. OQX is that is beta. This angle is beta. POX is alpha. QOX is beta. We have to find POQ. The angle is POQ. POQ is the total angle is POX is alpha. Total angle is alpha. And QOX is beta. We have to find POQ is alpha minus beta. POX minus QOX. Therefore, POQ equal to POQ is POX minus QOX. This is alpha minus beta. The angle is alpha. POQ is alpha minus beta. It is alpha minus beta. The next one, now find the coordinate of P and Q. Coordinate of P and Q. The coordinate of P is, that is the coordinate is x comma y. X-axis and y. The coordinate of P is, first one, now draw the line PM is perpendicular to the x-axis. Now draw the line PM is perpendicular to the x-axis. PM is perpendicular to the x-axis. Now find the coordinate of P. That is a right angle triangle. OMP be a right angle triangle. Now find the coordinate x-axis is where x is OM. That is x is OM and y is PM. Y is PM. Now find the x-axis OM is, that is the theta, where theta is alpha. Now find the OM is, that is adjacent side. This is a right angle triangle, is a adjacent side. That is hypotenuse is unit value. That is 1. OQ is 1. Now find the adjacent side. Adjacent by hypotenuse is cos theta. Adjacent by hypotenuse is cos theta. Now find the OM is x-axis. Where x is cos theta, that is theta value is in alpha. It is cos alpha. The x coordinate is cos alpha. And the y coordinate is PM. PM is opposite side. Opposite by hypotenuse. Opposite by hypotenuse is sin theta. That is theta value is alpha. That is the y axis is sin alpha. Therefore, the coordinate of P is cos alpha comma sin alpha. The first one coordinate is over. P coordinate is over. Next one, the coordinate Q is. Now find the coordinate of Q. The next one, now draw the line is perpendicular to the x-axis. Qn is perpendicular to the x-axis. Qn is perpendicular to the x-axis. It is a right angle triangle. It is a right angle triangle. That is the angle is beta. That is the angle is beta. Now find the x-axis is ON. ON is the x-axis. Now ON is the x-axis, where x-axis is, that is adjacent side. Adjacent by hypotenuse. Adjacent by hypotenuse already know cos theta, where theta is, that is beta angle between, this one is beta, that is cos beta, comma. Next one y-axis is NQ. NQ is opposite side. Opposite by hypotenuse is sin theta. Theta is the beta, sin beta. This sin beta. Therefore, the coordinate of P and Q is P is cos alpha comma sin alpha and coordinate of q is cos beta comma sin beta. The next one, the unit vectors I vector and j vector along x-axis and y-axis. The first one, I vector is along to x-axis and j vector is along to y-axis. This one, now here to prove sin alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. That is a proof. So take the 2 points. Take the points. Take the points P and Q on the unit circle with the center at origin O. Take the 2 points P and Q on the unit circle with the center at origin O. Assume that OP and OQ make angles alpha and beta. OP, OQ make angle alpha and beta with the x-axis respectively. Now find POQ. POQ is already you know. POQ is POX minus QOX. POX minus QOX is alpha minus beta. Therefore, POQ is, that is angle POQ equal to alpha minus beta. You have to prove the result is sin of alpha minus beta is alpha minus beta. Clearly, the coordinate of P and Q is the coordinate of P and Q here. P is cos alpha, comma sin alpha, and the coordinate of Q is cos beta, comma sin beta. That is the coordinate of P and Q. The next one, unit vectors I vector and j vector along x-axis and y-axis. The unit vectors I vector and j vector along x and y-axis. First now find OP vector. You take the right angle triangle OMP. First now find the OP vector. OP vector, how to write the OP vector? OP vector equal to, that is the vector. OP, this direction is OP. OP vector equal to OM plus MP vector. It is a right angle triangle. OP vector is OM plus MP vector. OM vector plus MP vector. OM plus MP vector. Where OM is the cos theta. OM is the x-axis. That is the x-coordinate. That is the coordinate of x is the cos alpha. That is OM is cos alpha. X-axis lies in the unit vector is I vector. Cos alpha I vector plus MP is the y coordinate. Y coordinate is lies in the sin alpha. That is sin alpha. Y-axis lies in j vector. Cos alpha I vector plus sin alpha j vector is OP vector. That is OP vector equal to cos alpha I plus sin alpha j vector. The next one, OQ vector equal to OQ. It is a vector. OQ vector equal. OQ vector is ON plus NQ vector. This is a right angle triangle. OQ is ON plus NQ. This is a direction. OQ vector equal to ON vector plus NQ vector. ON plus NQ. Where ON is x coordinate. That is, the x coordinate is cos beta. This cos beta, x axis lies in I vector plus sin beta j vector. That is a OQ vector. OQ vector is cos beta I vector plus sin beta j vector is OQ vector. That is OQ vector. Now find the cross product using the sin theta is using a cross product. Cross product is, take the first one is OQ vector. OQ vector cross OP vector. OQ cross OP. OQ cross OP. OQ cross OP. First, vector product of two vectors is vector product by using the definition A vector cross B vector. A vector cross B vector equal to vector product of two vectors is a determinant of I vector, J vector, K vector, the component of A and the component of B. That is OQ cross OP. First you write in determinant form, that is the determinant of I vector, J vector and K vector. The next one, the component of OQ is, the component of OQ is this one, cos beta I vector, sin beta J vector. The sin beta J vector, that is the first one, the coefficient of I is cos beta. This cos beta and J is sin beta and K is 0. The K is not value, that is 0. The next one, the component of OP is, the coefficient of I and J. The coefficient of I and J, I is cos alpha. This cos alpha and the coefficient of J is sin alpha. And next one, K value is 0. K is 0. The next one, now expand the determinants. First one you take I vector into this row and column are eliminating, getting the minor matrix. Sin beta into 0 is 0. 0 into sin alpha value is 0. The first one take the element I, the first value is 0. Next take the element J, column and row are eliminating, getting a minor matrix. Cos beta 0, cos alpha and 0. Now multiply cos beta into 0 is 0. Minus cos alpha into 0 is 0. J value is 0. The last one, taking the element K, column and row are eliminated, getting the minor matrix. Minor matrix is cos beta, sin beta, cos alpha, sin alpha. Now multiply cos beta, sin alpha, cos beta, minus cos alpha, sin beta. That is K vector into sin alpha, cos beta, minus cos alpha, sin beta. This is equation number 1. That is equation number 1. OQ cross OP equal to K vector into sin alpha cos beta minus cos alpha sin beta. That is equation number 1. By using the definition, next one, by definition of OQ cross OP, by the definition of vector product. By the definition of vector product is A vector cross B vector equal to A vector cross B vector equal to modulus of A vector, modulus of B vector into sin theta n cap, where n cap is the unit vector. Now OQ cross OP, by the definition, OQ cross OP is modulus of this, modulus of OP vector, modulus of OQ vector into sin theta, where theta is alpha minus beta. That is, the theta is alpha minus beta. Alpha minus beta into, that is the unit vector is K vector. The unit is K vector. OP vector, OP is the unit vector value is 1. OQ is also 1. 1 into 1. Sin of alpha minus beta into K vector. Alpha minus beta into K vector. 1 into 1 is 1. 1 into sin alpha minus beta is sin of alpha minus beta into K vector. That is equation number 2. This is equation number 2. From equation 1 and 2 we get, from equation 1 and 2 we get, first equation is K vector into sin alpha cos beta minus cos alpha sin beta, and the second equation sin of alpha minus beta into K vector, that is sin of alpha minus beta into K vector equal to K vector into sin alpha cos beta minus cos alpha sin beta. This K vectors are cancelled. That is, the result is sin of alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. That is, the result is sin of alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta, hence prove. Hence prove. Similarly we can prove the result is prove by vector method sin of alpha plus beta. Alpha plus beta. Sin of alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Similarly we can prove. Only the diagram change. Taking the 2 points P and Q lies in the first quadrant is alpha minus beta. The angle is alpha minus beta. Taking the 2 points lies in the first quadrant. Given the angle is alpha plus beta, taking the 2 points P and Q lies in the first point is P is the first quadrant and Q is the fourth quadrant. Now verify the second result. Sin of alpha plus beta. That is an exercise problem. Prove by vector method sin of alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Similarly, same methods. Taking the 2 points, the diagram only change. Taking the 2 points, first and fourth quadrant. The first point is P lies in the first quadrant and Q lies in the fourth quadrant. This QOX make an angle is, that is beta. This angle is beta. This one is alpha. This POX is alpha. And QOX is beta. Next PM is perpendicular to the x-axis. Next one, QN is perpendicular to the y-axis. QN is perpendicular to the y-axis. Next one, POQ. Now find the angle POQ is POQ equal to POX plus QOX is alpha plus beta. That is alpha is POX and beta is QOX. Now we find POQ is two angles. Add the two angles. That is alpha plus beta. POQ equal to POX plus QOX. That is alpha plus beta. The angle is alpha plus beta. Now find the coordinate is the same. P is cos alpha, sin alpha, and Q is, that is the x-axis cos, that is theta adjacent by hypotenuse cos beta. The next one, NQ is, that is theta opposite by hypotenuse. Opposite side is sin theta. That theta is the angle is beta. That is sin beta. The coordinate of x and y is lies in the fourth quadrant. Fourth quadrant is x is positive and y is a negative value. That is cos beta minus, where y coordinate is negative value, minus sin beta. The coordinate of q is cos beta minus sin beta. The same procedure. Take the points P and Q on the unit circle, the center O. Assume that the angle OP, OQ make an angle alpha beta with respect to x-axis. POQ equal to alpha plus beta. Clearly, the coordinate of P and Q is, the coordinate of P is same, cos alpha, sin alpha lies in a first quadrant. And Q is cos beta minus sin beta. Q of cos beta minus sin beta lies in a fourth quadrant, cos beta minus sin beta. That is the coordinate of Q. The next one, the unit vectors I and j along x and y axis. Next one, OP vector is OM plus MP. OP vector is cos alpha I vector plus sin alpha j vector. Same. OQ is ON plus NQ. OQ vector equal to cos beta I vector, where NQ is, that is the NQ is, lies in the y axis. Y axis is, the coordinate is minus sin beta. That is minus sin beta. Or sin of minus beta. Sin of minus theta equal to minus sin theta. That is, the value is minus. OQ vector equal to cos beta I vector minus sin beta j vector. Now find OQ cross OP. The component of OQ is cos beta minus sin beta. Cos beta minus sin beta. Next value, k value is 0. The component of OP is cos alpha sin alpha 0. Now expand the determinant. I value 0, j value 0 and k value only. K vector into sin alpha cos beta minus cos alpha sin beta. Already minus here. Minus into minus is plus. K vector into sin alpha cos beta plus cos alpha sin beta. By using the definition. That is OP, OQ, sin alpha plus beta. This angle is alpha plus beta. The second result is sin of alpha plus beta into K vector. From equation 1 and 2 we get sin of alpha plus beta equal to sin alpha cos beta. This one is plus sin alpha cos beta plus cos alpha sin beta. That is sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Therefore, the second result is proved. Next example 6.7. Prove by vector method the perpendicular means altitudes from the vertices to the opposite sides of a triangle are concurrent. That is, we have to prove three altitudes are concurrent or altitudes of a triangle are concurrent. Now, first draw the diagram in triangle. Now, draw the triangle A, B, C be the triangle. A, B, C be the triangle. The next one, draw the altitudes. Altitude is AD is perpendicular to the BC, perpendicular to the line, the opposite side. That is AD is perpendicular to the BC. That is the first one altitude. The next one, the perpendicular line is altitudes in opposite side. The next one, BE is perpendicular to the AC, CA or AC, anyone. B is perpendicular to CA. That is the second altitude. And third one is CF. CF is perpendicular to the AB. CF is perpendicular to AB. Three altitudes are concurrent means three altitudes lies in the same point or intersect a one point is 0 or O. Three altitudes, now we have to prove three altitudes are concurrent. The first one you take, first altitude is AD. AD and BE. Now taking two altitudes, AD and BE intersecting at a point O. AD, BE intersecting at a point O. We have to prove CO is perpendicular to AB or CF is perpendicular to AB. Taking two altitudes AD and BE intersecting at a point O, therefore we have to prove CF is also intersecting at a point O. So CF is perpendicular to AB. We have to prove CF is perpendicular to AB, therefore three altitudes are concurrent. The first one, taking the triangle, let A, B, C be a triangle. Let A, B, C be a triangle. Let A, B, C be a triangle. Let AD, BE intersecting at O. AD and BE intersect at O. Intersect at O. In order to prove that altitudes are concurrent. In order to prove that the altitudes are concurrent. The altitudes are concurrent. It is sufficient to prove. CO is perpendicular to AB or CF is perpendicular to AB. CO is perpendicular to AB or CF is perpendicular to AB. We have to prove CO is perpendicular to AB or CF is perpendicular to AB. First one, let O be the origin. Let O be the origin. The position vectors of A, B, C is, the position vector is OA vector. The position vector is OA vector. First one is take OA vector equal to small a vector. And next one, the position of OB is small b vector. And the position of OC vector equal to small c vector. Therefore, the position of A vector, capital A, B, C vector is small a vector, small b vector, and small c vector be a position vectors. Let OA vector equal to, that is OA vector, the position of OA vector equal to small a vector, and the position of OB vector equal to small b vector, and the position of C vector equal to OC vector equal to small c vector. The position of capital A, B, C is small a vector, small b, and small c. This OA vector equal to A vector, OB is B vector, and OC vector equal to C vector. That is the position of A, B, C. The next one, we have to find three altitudes are concurrent. First, I am taking AD, the first altitude. AD is perpendicular to BC. The first one altitude is AD is perpendicular to BC. The first one. First altitude AD is perpendicular to BC. First one AD is perpendicular to BC. The vector is, now change the vector. AD that is the intersect point is O. The AD, the altitude is intersecting at a point O. Therefore, OA is perpendicular to BC. Now we can write OA is perpendicular to BC. First one AD is perpendicular to BC. That is implies OA vector. Now change the vector. OA is perpendicular to OA vector is perpendicular to BC. OA vector is perpendicular to BC. AD, first one you take the altitude, AD is perpendicular to BC. Now write in a vector, OA vector is perpendicular to BC. OA vector is perpendicular to BC. Two vectors are perpendicular. A vector is perpendicular to B vector. By using the dot product, A vector dot B vector values is 0. OA vector is perpendicular to BC, that is implies OA vector dot BC dot product values is 0. Two vectors are perpendicular, dot product values is 0. OA vector dot BC vector equal to 0. That is implies that OA vector is the position vector. OA vector equal to A vector. Now we write the next step. OA vector dot, that is a BC vector. The position of BC is, the position of BC vector equal to OC vector minus OB vector. Already you know the position vectors. BC is OC minus O. OC minus OB vector equal to 0. 0 vector or 0, anyone. That is implies OA vector is the position vector, OA vector equal to A vector, small a vector. Is small a vector dot, OC vector is small c vector minus OB vector equal to B vector equal to 0. OA vector is small a and OC is small c minus B vector equal to 0. Now dot product of A vector, A dot c, first one multiply A dot c minus A vector dot B vector equal to 0. The first one is A dot c minus A dot B equal to 0. This is equation number 1. Taking the first altitude is AD is perpendicular to BC. Now take the second altitude B. The second altitude is B is perpendicular to CA. B is perpendicular to, that is the second one. First one is AD is perpendicular to BC, and the second one is B is perpendicular to CA. The second altitude B is perpendicular to CA. Now writing a vector, that is B is perpendicular to CA. Therefore OB vector is perpendicular to CA. This implies OB vector is perpendicular to CA. This is a vector. OB vector is perpendicular to CA. This OB vector, writing the same. OB vector is perpendicular means two vectors are perpendicular, dot product values is 0. OB vector dot CA vector equal to 0. OB vector dot, two vectors are perpendicular, scalar product or dot product values is 0. OB vector dot CA vector equal to 0. That is OB vector dot CA, the position of CA is OA minus OC equal to 0. OA minus OC equal to 0. That is implies OB vector is small b vector, b vector dot OA vector is small a vector minus c vector, it is equal to 0. Now multiply b vector. B vector is implies b vector dot a vector. B vector dot a vector minus b vector dot c vector. B vector dot c vector equal to 0. That is implies this one b dot a is a dot b. Scalar property is commutative. It is a vector dot b vector minus b vector dot c vector equal to 0. This is equation number 2. Equation number 2. Adding the equation 1 and 2. The first equation is a dot c, a dot b equal to 0, and second equation a dot b minus b dot c equal to 0. Now adding the two equations, adding the equation 1 and 2. First equation is a dot c minus a dot b plus a vector dot b vector minus b vector dot c vector equal to 0. This one minus a dot b plus a dot b. These two terms are cancelled. Remaining a vector dot c vector minus b vector dot c vector equal to 0. A dot c minus b dot c equal to 0. Taking the common value is that is c vector dot, that is a common. The outside is a minus b vector equal to 0. C vector dot a minus b vector equal to 0. So this is c vector is the position is OC vector. This OC vector dot a vector in the position of a is OA vector minus the b vector in the position is OB vector equal to 0. This OC vector dot OA minus OB. OA minus OB the position of BA vector. The position of BA vector, that is BA vector, the position of BA is OA minus OB. OC vector dot BA vector equal to 0. OC vector dot BA vector equal to 0. The dot product of two vectors equal to 0. Two vectors are perpendicular. That is OC is perpendicular to B or AB. OC is perpendicular to AB. Therefore, the third result is proved. OC is perpendicular to AB. Therefore, altitudes of a triangle are concurrent. Therefore, altitudes of a triangle are concurrent.